Notes 1.5 are about adding, subtracting, and multiplying polynomials. So let's take a look at what's written on the top of your notes that you're looking at right now. It says when we are working with polynomial expressions, a sum or difference of two or more terms. Okay, so that's what a polynomial expression is right here that we're talking about right here. We can only put things that are alike together. So for example, pretend that x squared is the same as an apple and x to the fourth is the same as an orange, okay? So I can say that x squared plus x squared means I have an apple and an apple, which is two apples. So I can say that it's 2x squared, okay? And if I have x to the fourth plus x to the fourth, I can say that's the same thing as an orange and an orange, so I've really got two oranges, so this is 2x to the fourth power. But if I have x squared plus x to the fourth, you get an apple and an orange, and you can't combine apples and oranges together, so it remains x squared plus x to the fourth power. So again, you can only put terms that are alike together. What makes terms alike is that they have to have the same variable and the same exponent. Okay, so the variable and the exponent are the same. So, for example, with the apples and oranges that we have right here, we have the same variable, but we don't have the same exponent, so they're not considered like terms. So now let's define the following words, because we talk about what polynomials are, but we don't actually have them defined. So let's define them. A polynomial is just basically one or more algebraic terms. Okay, and then so based on that, poly, hopefully you understand poly means many, so that's where we have this one or more. Okay, monomial means one algebraic term. Hopefully you understand then that binomial means two algebraic terms. And then a trinomial is just three algebraic terms. Alright, so let's look at what we have here. Find each sum or difference by combining the parts that are alike. So now the first question that you have here is super easy. You guys can just add 417 with 231 together. You do this all the time. So you end up getting, right here, you would end up getting 7 plus 1 is 8, 1 plus 3 is 4, 4 plus 2 is 6, right? But really, technically what you're doing is you are adding this 417, which is 4 hundredths, 1 10, and 7 ones. And then you're also adding 231, so you've got 2 hundredths, 3 tens, and 1 1, so you've got 6 hundredths altogether, 4 tens, and 8 ones. So why on earth am I even talking about this? Because this is really basic addition stuff that you've learned like at the beginning of elementary school. But it applies to algebra as well. So if you look right here in question number 2, I'm going to combine 4x squared together with 2x squared. Now I cannot combine it with any other terms because only these two are like each other because they have the same variable and the same exponent. So if I have 4x squareds and then I add another 2x squareds, it means altogether I have 6x squareds. It doesn't become 6x to the fourth or anything like that. It's just saying that I've got 6 sets of x squared, okay? And then I'm going to add this x to this 3x because those are like terms. So I end up getting 4x. And then I'm going to add this 7 to this 1 and I get 8. Because again, those are like terms. So really, you do this all the time. See how this says 4 hundredths? This is 4x squared. See how this says 110? This is 1x. See how this says 7 ones? Here's my 7, okay? And then here, you've got 231. So here's my 2 hundredths, here's my 3 tens, and here's my 1 1. So altogether, I've got 6 hundredths, 4 tens, and 8 ones. Okay, so the whole point of doing this was to see the relationship between the two right here. Now, if you look at question number 3, you have 3x cubed minus x squared minus the quantity x cubed plus 5x squared plus 4x minus 7. So I want you guys to be really careful about this. This time we are subtracting. So I'm going to do 3x cubed and I'm going to subtract x cubed, so I end up getting 2x cubed. Now, here's where people start to mess up. They think that I should do negative x squared, combine that with 5x squared, but it's not right because this is subtraction, so it's really negative x squared minus 5x squared, which is negative 6x squared. But what I suggest you do to make things easier on yourself is to go through and change this minus sign into a plus sign. So make this a positive, and then everything in the set of parentheses that follow, change it to its opposite. So this x cubed would become a negative x cubed. Okay? This 5x squared becomes a negative 5x squared. This 4x becomes a negative 4x, and this negative 7 becomes a positive 7. But I'm only changing everything that comes after the subtraction sign because I'm subtracting this whole expression, okay? So I end up getting 2x cubed for this one right here because I'm combining 3x cubed with negative x cubed now. And then this becomes negative 6x squared because I'm combining negative x squared with negative 5x squared. Now, there's nothing to combine with this negative 4x, so I'm just going to copy it down because there's nothing like it over here. So I've got negative 4x, and then lastly, I've got 8 and 7 left over, so I've got plus 15. So that's my answer for this. Now, if you remember in the last video, I told you, don't worry about the order. We'll talk about the order next time we discuss something in class. Well, we're going to talk about the order in this video. It must be written in descending order, and what descending order means is that it has to go from the highest exponent, descending order. It means you're going to go from the highest exponent to the lowest exponent. It has nothing to do with the coefficients though, okay? So, for example, my exponent here is 3, then I have 2, then I have 1, and then this is technically to the 0th power because there's no x's there, okay? Hopefully that makes sense to you. So let's go ahead and look at question number 3. And number 3, before I can do any adding or subtracting, I have to do some distributing. So I'm going to distribute this 3 to everybody inside of here. So this 3 gets distributed to this x cubed, so I get 3x cubed. Okay, and then this 3 gets distributed to this 8x, so I end up getting 24x. And then I'm going to distribute this negative 2 through, so I get negative 2x cubed. And then I get negative 24. Okay, now combine your like terms. So this 3x cubed is going to get combined with this negative 2x cubed, and I get 1x cubed. Okay, and then I've got this 24x is not being combined with anything else, so I'm just going to copy down plus 24x. And then the minus 24 is not being combined with anything else, so this is minus 24. And that's my final answer. Okay, I want you to take a moment and try number 5. And 6, press pause, come back to me when you are all set to go. I will give you the answers, and if you have something wrong, make sure you ask me next time I see you in class so that you can understand what your mistakes are. Okay, go ahead, press pause, try 5 and 6, and come back to me. All right, and number 5, this 5 isn't going to be combined with anything else, so I'm going to copy it down, okay? This negative t gets combined with this 9t, so I end up getting 8t, okay? And then this negative t squared gets combined with this positive t squared, but you've got negative 1 and positive 1, so they cancel each other out. So this is your answer, but it has to be written in descending order, so your answer would be 8t plus 5, okay? And then for question number 6, 3p plus 1 is written in parentheses, but there's really nothing I can do with the parentheses, so I'm just going to copy it down without the parentheses. Here there's parentheses because I have to distribute that 6 through, so hopefully you got 6p minus 48. And hopefully here you understood that you had to distribute the negative through, so you get negative p minus 2. Combine your like terms, so 3p goes with 6p goes with negative p, you end up getting 8p. Okay, and then this 1 will go with this negative 48 and this negative 2, and hopefully you ended up getting negative 49. Okay, let me rewrite this a little bit better so you can see it in case you're confused by my answer. So this is negative 49. Hopefully that makes sense to you. Now we're going to talk about what happens when we multiply. So when multiplying powers with the same base, you blank the exponents. Hopefully you know this blank right here that you should add the exponents, okay? And then multiply the numbers in front of the exponents, which are the coefficients. So after you write this down, I want you to take a minute, try questions 7 and 8, and then come back to me to see how you did. Okay, In number 7, you should get x to the 7th power because 3 plus 4 is 7, okay? And then in number 8, you should get 10x to the 15th power because 5 times 2 is 10, and then 8 plus 7 is 15, okay? Now let's look at number 9. Gisela computed 342 times 23 as follows. So she has, she did 300 here, 40 here, and 2 here because she just broke it up into the different pieces right here, okay? And then 20 and 3 were right here because, again, she broke it up into the different pieces. So can you explain what she's doing? So hopefully you understand that what she's doing is that she is just splitting it all up right here. So that way she ends up getting, right here, she's got 6,000, okay? Where does she get this 1,700 from? Hopefully you understood or can see that she's getting it from adding these diagonals together, okay? Notice how it's kind of like she's combining her like terms, right? Here's your thousands place, here are your hundreds, so you combine those guys together. This 160 came from combining the 40 and the 120 together. There's your tens, and then this is your ones, okay? So then the final answer would be 6,000 plus 1,700 plus 160 plus 6, so you end up getting 7,866. So use the geometric diagram to find the following product. So let's do question number 10, and in question number 10, we are going to have a 3x2 or a 2x3. It's up to you however you want to do it. I'm going to have a 3x2 this way so that you can kind of see the relationship between this and the previous example. So we have 3x squared and then 4x and 2 right here. And then on the side, I'm going to put 2x and 3 right here. So what I'm going to do is I'm just going to multiply. So right here, this box would be 2x times 3x squared, which is 6x to the 3rd power because you multiply your coefficients and you add your exponents, okay? This would end up being 8x squared, and then this would end up being 4, okay? This here would be 9x squared, this would be 12x, and this would be 6. So now, remember before, we combined these two together because they were like terms in the previous example on the up in the middle of the page. So remember we said that we were going to combine this 800 with this 900 together, and that's how we got the 1,700. So here we're going to combine the 8x squared with the 9x squared, and that's how we get 17x squared. And then here we're going to combine, I'm sorry, there's a mistake. This right here should be 4x, not just 4. So here we're going to combine the 4x and the 12x together, and you end up getting 16x. Okay, so that means that your final answer will end up being 6x cubed plus 17x squared plus 16x plus 6, which is basically what we had before. This 6,000 is like the 6x squared. This 1,700 is like the 17x squared. This set of 16 tens is like the 16x, and the 6 is like the 6. Okay, all right, so what I want you to do is use a geometric model to do question number 11. I'm going to have you do all of number 11 on your own, and then come back to me when you're done to see how you did, and we'll go from there. All right, take a look at number 11. All the work is on this page right here. So if you could take a look at it and make sure you did it right. If you need to, press pause so that way you can correct any mistakes if you made any mistakes, and just so you can just double check to make sure everything is good. All right, I'm going to go on to number 12. Multiply the polynomials using the distributive property. Now, if you notice, it's the exact same question, except we're using the distributive property this time instead. So I'm going to color code it so you can kind of see this a little better. So I'm going to call the first trinomial, I'm going to use blue, and then the second trinomial, I'm going to use red. So basically, you guys already know how to do distributing. For example, if I gave you a problem that said 5 times x plus 4, you would know to take the 5 and multiply it by the x, and take the 5 and multiply it by the 4, and you get 5x plus 20, right? But in this example that you have right here on number 12, you have a trinomial times a trinomial as opposed to just one single number on the outside. But you're still going to go through and distribute everything. So see this 2x squared to begin with? I'm going to write down that I'm going to distribute it to everybody inside of the second set of parentheses right here. So I'm going to multiply it by x squared plus x minus 3. okay? And then I'm going to do the same thing with this negative 10x. Distribute it through to the x squared plus x minus 3. And then lastly, I'm going to do the same thing with the 1. Again, I'm getting these numbers from this set of, the numbers in this trinomial. So I'm going to have 1, and then I'm going to have x squared plus x minus 3. All right? And then once I've done that, the rest is easy. I just have to do my distributing. So let's go ahead and do our distributing right here. So the first term, you end up getting 2x to the 4th power, right? And then here you get 2x to the 3rd power. And then lastly, you end up getting 2x squared minus 3, which gives you negative 6x squared. All right? Notice how everything in this column lines up with everything that we have right here. Now the next one, you have to be really careful when you distribute that negative, okay? So this ends up being negative 10x cubed minus 10x squared plus positive 30x, okay? And same thing, look right here, it's the exact same numbers that we have in that column, okay? And then the last expression that we end up getting when we distribute the 1 through, that's easy. You get x squared plus x minus 3, which again is what you have in this column. So if you notice, it's really essentially the same thing. So at this point in time, you can choose to use the box or just writing out the distributing, whatever works best for you. Last thing I need to do is just combine my like terms. There's nothing like 2x to the 4th power, so I'm just going to copy it down. 2x cubed is like negative 10x cubed, so I get negative 8x cubed. Negative 6x squared is like negative 10x squared, and x squared, so negative 6 plus negative 10 is negative 16 plus 1 is negative 15x squared. Okay, this 30x is like this x, so I end up getting 31x. And then I have this minus 3 left over at the end. Okay, and that is my final answer. So again, you can choose, do you want to distribute or do you want to use the geometric model? It is 100% your choice.